Oh, you're talking about jumper. That's a different one.
It's not the same.
Did we see this was the last?
No, blank slide was that.
You don't know the word.
But this one came before the first.
Mandibular. The opposite.
Did you have a class before that?
Yes, ma'am.
Did you finish reading it?
No.
No, technically, yes.
At time.
Who's the
You
You are usually with professor?
We argue about the grade.
Okay, let's go ahead and start. I'm just about video.
فاتحين مطعم.
خلص بس فوق خليه برا سكر الباب.
Step 2.
Okay, well last was it yesterday?
Yesterday.
Okay, we were talking about growth hormone and we said it promotes growth everywhere. It has a very powerful effect on the skeleton mainly, but of course it has an effect on all cells that are willing to grow. And of course if you have an increase in growth hormone during when a person is still growing, everything will grow proportionally. So these people will become tall, but at least everything will be proportional. Why? Because the long shafts of the long bones have already fused. They have not been fused yet with the epiphysis, so you still have room for these bones to become even longer. And of course, it promotes osteoblastic activities and all that, so you have proportional growth. But if it happens in adulthood, then of course the long bones have already fused with the epiphysis, no more, not going to become any taller, but these bones become thick. And this is one picture where a person has a lot of growth hormone, and it is called acromegaly, which is the enlargement of a lot of things in their body. And this is a picture of the face. You can see the jaw becomes larger and protrudes, as well as the same thing happens with the forehead, and even the whole skull increases in size. Now and then you have these releasing hormones that come from the hypothalamus, and then they act with the anterior pituitary. Well, anterior pituitary releases hormones. Some of them are hormones like growth hormone and prolactin. Some are stimulating hormone that go somewhere else to stimulate such, for example, the secretion and synthesis of thyroid hormones. But now we want to see how does growth hormone work? Does it go directly to the cells and make them large? It turns out that if you incubate cultured cells with growth hormone, they do not grow. Okay? So that tells you right there, if you're an experimentalist, you do experiment, that there is something, that growth hormone does not cause the growth by itself. There must be some other mediators. Some other mediator that, of course, might not be in existence in vitro or in the culture. And sure enough, growth hormone is not the last step in this growth. Apparently, it increases the synthesis and the release of proteins from the liver. These are called somatomidins, or insulin-like growth factors, IGFs. And the most important one of them that apparently causes the growth that is caused by growth hormone is somatomidin C, or growth hormone, insulin-like growth hormone 1. Okay, and these have been isolated, and if you're interested in their size, molecular weight, it's right there. Well, now, another example that shows you that growth hormone is probably not acting directly itself to cause growth is the situation with the pygmies of Africa. I don't know, have you ever seen those?
Small rodents.
This is a tribe that, no, small rodents, no, that's a human. Yeah, they're very nice people, but they are short, 5 feet, something like that. It's a tribe somewhere in the southern part of Africa. And these people have normal growth hormone levels. Sometimes they even have higher than normal growth hormone levels, but they're short. And the reason for that is apparently they do not have the ability to make a normal amount of somatostatin C or insulin-like growth factor 1. Okay, so these two examples tell you that apparently most of the effects, maybe not all the effects, but most of the effects of growth hormone are mediated by these growth factors. The same thing happens with another form of dwarfism.
Lorient dwarf.
Yeah, do you know how?
Lorient dwarf.
Yeah, it's a form of dwarfism, but not in the pygmies. White people. Don't read this, but this is because we really don't know. We are not 100% sure that we have some evidence indicating that growth hormone, yes, can grow things directly. We have some of this evidence from experiments, and we have also other evidences from experiments as well as from examples such as the pygmies and the Lorraine, that dwarfism, that growth hormone probably its effect is mediated through these growth factors. But in reality, in some experiments, you can put growth hormone in culture, and you are able to see some growth of these cells. So the hypothesis that has been introduced, and again, this probably is a good hypothesis until we find the real proof behind this, is probably in vitro. Even though you are putting growth hormone in vitro, probably these cells or the tissue that you are using might be able to produce itself growth hormone, like somatomedians. Or it could be that growth hormone can have a direct effect. I mean, both of them look like there is evidence to support both of them. For now, for our purposes, growth hormones, growth or its effects are mediated by growth factors, mainly IGF-1, that are produced by the liver. That's the party line that we will go with now. Okay? Well, now, growth hormone, again, some more information about growth hormone as well as these growth factors. Growth hormone, when released, of course, it circulates, right? It goes everywhere in the blood. It is bound to a plasma protein, okay, but it's weakly bound. So the binding is not very strong. Its half-life, the half-life of growth hormone, is only about 20 minutes. However, very often you will see growth for a lot longer period of time. And the reason for that is these growth factors, especially the somatomedin C, which is really mediating the functions of growth hormone, they bound to a plasma protein, but they have a longer half-life. They can practically stay around for about 20 hours. So that explains the long effect of growth hormone, despite the fact that its half-life is very short in plasma. Okay? And this is an example of what happens to growth hormone at different times. And we are telling you this, like some hormones, very often you have like a basal level all the time, or plus or minus. There's nothing perfect in the body, so plus or minus. But with growth hormone, you have pulsatile. If you look at the changes, you can see pulsatile changes in growth hormone during the day. You have strenuous exercise; it goes up significantly. During sleep, the first part of sleep, and it goes up and then it goes down. We don't know what causes that, but at least these are the patterns that you see with growth hormone. Okay.
مشان هيك بعضهم بيقولوا انت كل ما تنام تطول بعد واحد بيقول للثاني.
No,
They say they grow like a couple of inches
when you're asleep.
when you're sleeping, then when you wake up, you
Who said that?
اسمع كثير.
مين؟
اسمع كثير.
Yeah, I mean, I don't think these are grandmothers that say that. They probably didn't do that experiment. Okay, well, but a lot of these sayings, they come out of facts, observations that people used to observe before experiments, before our modern day, or modern age of doing experiments. A lot of these sayings, they seem to have some truth, even though they came out like 1,000 years ago. Okay, well now, also, we're talking about the patterns of growth hormone, but you can also expect them from the name, and we've been in medical school for now 1 year and a half, that probably growth hormone and what causes growth, so it's probably high, you will have higher levels in the period of your life when you are growing and when you are younger. And sure enough, that's true. With age, it starts going down, so in older age, you have a quarter of the amount that you have when you are younger. Now, growth hormone, this, in addition to the patterns that you see with sleep or with strenuous exercise, you also, there are some conditions that produce significant changes in growth hormone. Some of these things that stimulate growth hormone are starvation, hypoglycemia, exercise, like we said, excitement. It seems to increase also during trauma, and during deep sleep, and also in the presence of ghrelin. No.
Isn't it because for the first three reasons? Because in these situations we need glucose.
We need more protein too. We need more protein synthesis, right? Very often strenuous exercise will cause muscles to be damaged, so you need to repair them or even produce or promote mitosis, get new cells. So that explains it. Not everything we can explain, but at least we know, and during these circumstances, growth hormone is increased. Yes, ma'am.
Increase in all of these circumstances.
Yes. All these circumstances we're listing here cause the concentration of growth hormone in the plasma to go up. We will give you examples of, and this list here causes growth hormone to be down in the plasma. Decreased blood glucose will take it up, increased blood glucose will take it down, and some of them are opposite. Decreased blood-free fatty acids, increased blood-free fatty acids, right? Starvation, aging, I guess that's not the opposite. Okay, with aging it goes down. Obesity, again, because you probably have a lot of the opposite of having less fat. That's right. Trauma, stress, exercse all increase growth hormone. Growth hormone, inhibitory hormone decreases, right? But it's written out there. Another, this is not, what about growth hormone? If you give somebody growth hormone? Huh? Yes, negative feedback, so his production of growth hormone will go down, and his body will think we have a lot of it. Yeah, these are situations where growth hormone can be increased or decreased. Some we can explain, some they are simple observations. Okay, well now, what happens to growth hormones, or what kind of levels you expect to see in humans? Well, in adults, the amount varies, about 1.6, 1.5, something like that, to about 3 nanograms per milliliter. And when you're a child, it's even higher, it's about 6, and that makes sense because that's a period of high growth. And in old age, like we said, it can go down, but even during childhood, it can go up to 50 nanograms per milliliter, which is a great amount. Okay. Well now, what are the two situations where growth hormone productivity is affected very much? One of them is hypoglycemia. If you're talking about acute effects on growth hormone, hypoglycemia is quite effective in increasing growth hormone levels. But chronical, if you have chronic depletion of proteins, chronically,